About $185. That is what it recorded to take a single autonomous agent from an empty directory to 2 clean, dry run completions. But the very first run cost nothing at all. It died in 12 minutes at a permission dialog before the agent was ever trusted to touch the workspace. So here's the question this whole post-mortem answers. What does $185 of autonomous agent actually buy you? You have seen the demos. An agent takes a one-line prompt and a finished app falls out the other end. You have probably also tried it on something real and watched it stall, loop, or quietly burn your budget while you slept. The gap between the demo and the job is not intelligence. It is everything around the model, the permission prompt nobody answers in a headless run, the background task killed at a hard timeout, the cost ceiling that halts the run, pages you at 40 past midnight and then forgets it exists the moment the agent resumes. None of these are reasoning failures. They are operational failures, and they are the ones nobody films. This is the unglamorous middle of autonomous engineering, the stretch between the prompt and the artifact where real money leaks and real hours disappear. That middle is what we instrumented across 5 runs in 2 days. Everything here traces to one artifact, a run log the pipeline archives on every fresh start. 5 runs, timestamped to the second. Run 1, $0. Run 2, abandoned at $42 mid-resume. Run 3, $60.87 clean. Run 4, $82.05 clean. Every figure you see comes from that ledger. Nothing here is estimated. Start with the failure that costs nothing. Run 1, 10:21 p.m. on a Friday. The agent launched headless. No human at the keyboard, and immediately hit a trust dialog, the prompt that asks whether you trust the files in this workspace. In an interactive session, you tap yes. Headless, there is nobody to tap. The pipeline had an allow list of permissions, and the agent ignored it because the real gate was a single unset flag buried deeper in the configuration. The workspace was never trusted. 12 minutes later, the run failed at the spec phase, having spent, and I want to be exact here, $0. Here is the transferable part. The most expensive-looking failures in autonomous work are often the cheapest, and they live in your environment, not your model. A trust flag, a missing variable. The fix here was one line in a config file, set the accepted dialog flag, and run one's failure never happens again. Before you spend $1 of inference on a smarter agent, spend an hour making the boring environment deterministic. The agent cannot answer a dialog box. You have to remove the dialog box, which brings us to the failure that actually did cost money, the one that woke somebody up. Watch the counter climb toward $25, the ceiling, and then straight past it. 12:40 a.m., halt, $29.63 on a run that was supposed to stop at 25. Somebody's phone lit up in the dark. That halt is the moment the whole story turns. The pipeline had a cost ceiling, $25, and it worked exactly once. It caught the overrun, halted the run, and paged a human at 40 past midnight. Good. That is the guardrail doing its job. Then the human approved the resume, the agent picked up where it left off, and the ceiling did not come back. Look at the totals after the resume. $35.32, $39.67, $42.06. The run walked straight through the $25 line it had just halted on because the resume path never rechecked the ceiling. That is kit bug number 1, and it is the single most important thing in this entire report. A guardrail that only fires on the first pass is not a guardrail. It is a speed bump you drive over once. The same run had a twin defect. A pass counter that was supposed to cap the pipeline at 3 passes printed pass 4 of 3 and kept going. Max passes, like the cost ceiling, was not reinforced after resume. 2 separate limits, 1 root cause. Resume is a second entrance into your control loop, and every limit you enforce on the way in, you have to enforce again on the way back. The workaround was to raise the ceiling to $500 and the passes to 10. The real fix is still pending. This is the pipeline itself, the same one the first 4 runs shaped, running its phases end to end. No narration, no cuts. Just watch a machine work at a pace no human types at, and notice there is nobody in the room with it. Now, the failure that looks worst and is actually the system working. Across the runs, the end-to-end gate, the final check that the whole thing does what the spec demands, blocked over and over. Run 2, hit it 4 times, run 3 once, run 4 twice. If you only read the headline, this pipeline looks like it could not finish anything. Read the findings and it flips. Every single block was missing scope, never a broken build. The build loop shipped roughly 1 module per iteration. The safe fetch layer first, then metering and cache. The end-to-end gate demanded the entire definition of done, every acceptance criterion at once, so it kept saying not done, and it kept being right. At one abandonment point, whole files and directories the spec required simply did not exist yet. That is not a defect, that is a completeness ratchet, and it only ever turned forward. And the code underneath it was real. When the final gate did pass, it passed 110 tests out of 110, with all 12 server-side request forgery cases, attacks that trick a server into fetching a URL it should refuse, verified live. A separate security gate caught an authentication fail open and a domain name system rebinding attack in the render path and blocked until both were fixed. The takeaway: a gate that blocks a lot is not a broken gate. A gate that never blocks is the thing that should scare you. So what did the money actually build? This is the part the cost total hides. Runs 2 and 3 built a shared core. Configuration, authentication, error handling, health checks, the safe fetch layer, metering, caching, rendering, and the deploy scaffolding around it. Then run 4 did something more interesting. It built a second service, an audit service, on top of that core, and it froze the core while doing it. The end-to-end check confirmed it. The difference against the core directory and its test was empty. 0 lines changed. The agent extended the product without disturbing the foundation it had already shipped. That is not 2 builds of the same thing. That is 1 product growing. Run 4 is also where the pipeline caught itself being too obedient. The hardening reviewer suggested a literal 1-line fix. The builder applied it word for word, and it broke a frozen test. The reviewer had no shell, so it could not run anything, and it waved the change through. An independent tester caught it, 1 failed, 165 passed, and a fix-up reverted the line. The lesson the pipeline wrote for itself. A suggested 1-line fix is a suggestion, not a directive. Even inside an autonomous loop, you separate the agent that proposes from the agent that verifies, and you never let the one without a shell have the last word. So back to the question. About $185, about 45.5 hours, 5 runs, one of them abandoned in the dark. What did it buy? It bought a working shared core and a second service running on top of it, frozen and clean. 2 successive stages of 1 real product, verified by its own gates. And it bought something worth more than the code, a map of exactly where autonomous builds leak, not in the model's reasoning, in the seams, the trust dialog, the background timeout, and above all, the guardrail that forgets to guard the second time through. So here is your 1 action. Go find every limit in your own automation, cost, retrees, passes, and ask 1 question. Does it reinforce on resume? If you are not sure, it does not. Next video, I take kit bug number 1 and actually fix it on camera with the log to prove it held. That is the receipt I owe you.